Okay, in this video I plan on proving the three main laws of logarithms. So first off we have the law of multiplication, where if we want to take the logarithm of the product of two numbers, x times y, this is just the same as the sum of two logarithms, log of x plus log of y. And now the way we're going to show this is true is by deducing it from the laws of indices. So the laws of indices tell us how to manipulate exponentials, but we know that logarithms are just the inverse of exponentials, so we can just deduce it from that. Now the way I'm going to do that is I'm going to let this log to base a of x, I'm going to call this b, so I'm just going to label it a new variable. And the same for this one, I'm going to call this term log to base a of y, I'm going to call this c. And now by the definition of the logarithm, we can write this equivalently using exponentials. So this is the same, the first one, is the same as saying that x equals a to the power of b. And we can see this is true by just taking logarithms of this equation. So if we apply log to base a, left-hand side, it gives us exactly the left-hand side here. And if we apply log to the base a of the right-hand side, then we just get b, just by definition of log. So this is equivalent to this. And we can have a similar formulation for the bottom equation. So this is the same as y equals a to the power of c. So if you think about multiplying these two numbers, we have an x times y in here. So let's work out what x times y is. X times y is a to the power of b times a to the power of c. And then we have two exponents, they've got the same base, and the laws of indices tell us that we can just add these two numbers. So this is the same as a to the power of b plus c. So maybe now you can see why the multiplication turns into addition here. So to get back to our laws of logarithms, we need to convert this back into logarithms. So I'm just going to apply log to the base a of both sides. So log to base a of x times y, this is the same as log to base a of this right-hand side. So this is a to the power of b plus c. And by the definition of the logarithm, since we have a to the power of something and we're taking the logarithm of base a, our answer is just going to be the power. So it's just going to be b plus c. So log to the base a of x times y is equal to b plus c. But remember how we defined b and c? It's exactly this stuff. So if we just plug these back in, we get that log base a of x plus log base a of y, this is the right hand side, this equals to log of a of x times y. So this is how we've shown this law is true. The main result is from the law of indices, so it's kind of just a deduction. So now we're going to look at the second law, the law of division. So for this law, we're essentially going to take the same approach. I'm going to label this as b, so I'm going to call log base a of x, I'm going to call this b, just as before, and again I'm going to call this c, so I'm going to call this log to base a of y, I'm going to call this c. And then we want to translate everything in terms of exponentials again. And this we saw last time, this is the same as x equals a to the power of b, and then this equation is equivalent to y equals a to the power of c. Before we wanted to know what x times y was, this time we want to know what x divided by y is. So if we work this out, x divided by y, this is a to the power of b divided by a to the power of c. And now we apply the laws of indices. This tells us that if we divide two numbers which are exponents to the same base, we can just subtract the powers. So this is the same as a to the power of b minus a. And this is how we convert a division into a subtraction. So now the last step is the same. We want to convert this back into logarithms. So I'm just going to apply logarithms to base a of both sides. So log base a of x divided by y, this equals log to base a of this right-hand side, so a to the power of b minus a. And again, by the definition of log, it's the inverse of the exponential, so this just equals b minus c. And finally, we just want to convert back into logarithms, so by the definition of b and c, this is really the same as log base a of x minus log base a of y. And this is how we show it's true. So you've got one more law to prove, which is the power law. Okay, for the final law, we're going to take the same strategy again. So this law tells us that if we apply log of x to the power of k, we can bring the power out the front. And so as before, I'm going to define this logarithm to be b. So log base a of x, I'm just going to call this b. And then we want to express this in terms of exponentials. And we saw this is equivalent to x equals a to the power of b. So now we're just dealing with one logarithm, but this time we need to find out what x to the power of k is. So x to the power of k, if I just substitute what we found x to be, this is a to the power of b to the power of k. And now this is where we apply the law of indices again. If we have something to the power of a power, the laws of indices tell us we can just multiply these two numbers. So this is equal to a to the power of b times k. So now we convert it back into logarithms. So I apply log to the base a to both sides of these equations. So this is x to the k, and then this equals log to the base a of a to the power of b times k. And again, by the definition of logs, we just cancel out the base and we get b times k. And the final step is to substitute back in for b. So we said b was this logarithm. So this gives us the answer of k times log base a of x. And this is exactly what we wanted to show. So this is how to prove all the laws of logarithms.